Solving systems algebraically. I've written two different systems here, and I'm going to show you how to solve each one, or one of them by elimination and one of them by what's called substitution. I'm going to go through some tips that will help you organize your work while you're solving them, so that I and you and anybody else reading your work can easily read your work and understand the process that you used. Remember, we talk about organizing your work, showing your work, so that you can show your thought process in an efficient and communicative way. Here we have the system 4x minus 2y and 3x minus 3. 4x minus 2y equals negative 1. 3x minus 3y equals negative 3. We're going to solve this by elimination because each of the variables have a coefficient, and so elimination is a better process for this. Now I've written out the system separately so that we can, because we're going to have to rewrite each of the systems in order to combine them, in order to eliminate a variable. And so if we multiply this one by 3 and this one by negative 2, then each of the y will have the same coefficient. Let me show you what I mean. See, we have negative 6y, we have positive 6y. The coefficient is actually opposite. And so when we add them together, 12x minus 6y equals negative 3, and negative 6x plus 6y equals 6, the y variable will become 0 or eliminated. And we will have 6x equals negative or positive 3 divided by 6, x equals 1/2. Now that we have eliminated the y, we can solve for x, and then we can substitute the y value back in to one of the original equations. 4 times 1/2 minus 2y equals negative 1. Now we have a replacement for x, and so we can solve for y. 2 minus 2y equals negative 1. Subtract 2 on both sides. We have 2y equals negative 3, and y equals negative 3/2. And so the answer to, or the solution to this system is 1/2 negative 3/2. Now notice that I've written the system as an ordered pair, as a coordinate. We want to always think back to the equations as a graph. This represents a point on the graph at the intersection of the two equations. Now for substitution. For substitution, we want to substitute one of the equations, one of the variables in the equation. So our goal is to get one of the variables and solve for one of the variables. Here we can either choose y or x, and it doesn't really matter, but we do need to rewrite at least one of them. So again, I've written them separately so that we can easily do some work of rewriting and then do the work for solving. And so it makes it a nice ordered way and a nice way to easily see all the work that's being done here. I chose to go ahead and rewrite this. So now, since y equals negative 3x plus 6, whenever I see y in the other equation, I'm going to write 3x plus 6. It's important to use your parentheses. It's important to write the entire expression for y and replace it for the variable in the other equation. Now you can see that in a way we have eliminated y. There is now only x in this equation and we can solve. Now, as like what we did before, we can substitute in x equals 1 into the other equation. Actually, it doesn't matter which one we do. Let's go ahead and do this one because x is there in front. So I'm going to substitute 1 into this equation, and then we can solve for y. And then write the solution as an ordered pair.